I want to welcome everyone here today. And again, as Lori said, thank you for making the time to sit with us and look at this particular topic with 3D annotations in Inventor. Just real quick, I want to introduce myself. My name is Rusty Belcher. I appreciate Lori introducing me. My background in manufacturing comes from my time working at Newport Shipbuilding. That's where I went when I was 18 years old, and I was a steel worker there for 10 years on the waterfront. And then after that, through my apprenticeship, I ended up working in the mold loft there. And that was where I think that's where they gave me the AutoCAD one day, and we learned 3D modeling, and then that became, gosh, Mechanical Desktop, and that became Inventor. And I joke around a lot that people ask me, like, what version of AutoCAD did you use when you started? I don't remember, but I remember it was like Windows 95. That was what was on the computer back then. So I bring the shipyard up because I remember how we used to build ships back then, and that was my my trade that I apprenticed at. And I still live in Hampton, Virginia, which is just adjacent to Newport News, and I still get a chance to work with that great shipyard. I still support them in a lot of their Autodesk applications. And our topic today happens to be 3D annotations, and I think that shipyard probably is leading the nation in the ability to take 3D models, annotate them, send them out to the waterfront or to the trades, and have the people build them without drawings. It's something they adopted about 15 to 20 years ago, and Huntington Ingalls has a great YouTube channel, and I'd encourage anyone interested in really how this can be used to go out and take a look at that. I don't feel comfortable playing their videos on this webinar. I wouldn't do that to them. But I would encourage you, there are industries that have really adopted this model-based approach to manufacturing. So we are going to look at today, just an introduction, we're going to look at the three-dimensional annotation tools available in Inventor and also the publishing capabilities. So it's one thing to be able to put your annotations on 3D, but then how do you get that out to the field so that your fabrication team can look at the model on their little iPad or their little Windows Surface tablet, and how do they measure, and how do they redline, and how do they read this information? All of it is Inventor is absolutely capable of doing all of this, and I want to highlight where these tools are and how you can use them. So we're definitely going to take a look at that. Before I get started, I do want you to know that this presentation is really based upon a class that we offer at IMAGINiT. We have a working with 3D annotations model-based definition class. It is something that we offer our students. I just taught this class about 2 months ago to a group of people at another shipyard in my local area, and I was amazed at the class and the content. I don't get a chance to teach this very often, so it's just really nice to go through it. But I want everyone on the call to know that when it comes to IMAGINiT and training, we have amazing ways to deliver instructor-led training. We can have a class. I mentioned that class I taught. The shipyard came in and we had an in-person class. But of course, just like you guys are watching me today, we have online instructor-led training. You might be at home taking that class. You might be taking that class at work. But you would tie into our cloud-based computers, and you would see all the software you need to take the class. But we also have our support P-Now, our Productivity Now support page. So of course we offer support, and Productivity Now has levels of support. And if you have the highest level support for Productivity Now, you can actually go and take this class right away. The book and everything else is available to you, and it's all self-paced training. So if you're interested in this topic and you want to follow through with it, I want you to be assured there is a class material out there. Whether you take the class with us online or in person or through Productivity Now, we have the means to train you up in this particular function of the Inventor application. So I want to talk about model-based design right off the bat. And I think the introduction that you came in with is really perfect. So many designs in today's world, in the digital world that we live in, they are based upon a 3D model. And we have gotten so proficient at adding information to that model that in many situations, for instance, on a CNC machine, I don't send them a drawing. Well, the drawing's not necessarily as important as the model is. I send them the model, they generate the G code. I might make them a drawing to account for fit and finish, but that's it. They really depend on the 3D model to drive their code in the machine. If we could put everything necessary in the 3D model, then why are we still generating those traditional 2D drawings? I love that Inventor makes these drawings and it does such a fantastic job. But the digital world we live in is moving towards, hey, just give me the model. I'll pull it up on my device. I'll measure it. I'll build it however I feel comfortable building it. And that's the idea behind the 3D annotations. Because there are times where I need to put tolerances on a model, and that's not necessarily the easiest thing to model in 3D. So I need an annotation to carry my tolerance. I need an annotation to carry the fit and finish notes for my design. And I need to be able to reliably transfer that over to somebody else. If I'm not going to send them a drawing, I need a reliable way to transfer that information. So we're going to explore the 3D annotation capabilities today. So when you're in Inventor, all right, you have the Annotate tab. The Annotate tab has been a part of Inventor, I want to say, for the past at least 5 releases. So I'm pretty comfortable saying that. And the tab itself is broken up into different panels. So you have the geometric annotation panel, you have the general annotation panel, you have notes and the manage tab, and then the export tab. The annotate tab is where you'll find really all the 3D annotation tools that you need. So I'm going to start on the left side of this, and we're going to go through kind of feature by feature. I'll highlight the ones that I can, and I'll give you some quick examples of these as we go through them. But the geometric annotation panel is about geometric dimensioning and tolerancing, so GD&T. And I will tell you right off the bat, really important line here, GD&T does require some knowledge of GD&T. The tools that are supplied allow you to comply to standards, but you do have to understand GD&T. So there might be some additional training classes you have to go to, or some accreditation that you need to be a company, or you need to get to where you're fully GD&T ready. But you can add your tolerances to your design or to your dimensions, and you can account for things like the position of a hole or the perpendicularity of a given item or edge, the roundness of something, or the flatness of something. You can pull all of that information in through the GD&T tool. I think Autodesk did a very good job of recognizing that not everyone is really ready to jump into GD&T. So there is a tolerance advisor, and this will analyze your model It basically looks at what you've done and runs a logical routine to say if you've defined enough information. It's not foolproof. Believe me, I'm the biggest fool when it comes to GD&T, but it is a nice tool to rely on to really check behind you and see if you've given enough information. So once you define your datum planes, and then you define the features that are in position based on your datum planes, it keeps track of that. So it's a nice enhancement to have. Again, it does not tell you if you've toleranced the model correctly. And that's where, you know, we rely on you being the engineer and understanding GD&T. But it is available to you. The next annotation tool is the dimension tool, and the general dimension tool, and it's considered a general annotation. And I think if you can add a dimension in Paperspace or in the model, I'm sorry, in the drawing, you can easily add a dimension inside of the 3D tolerance area. One of the things I should have mentioned before, and bear with me, on GD&T, GD&T is only available in a part file. So you, if you're in an assembly, you won't have these options available. So I want to make sure I say that. But on the dimension side of things, on the general annotation side, these things are, again, they're very simple to add. They are quite versatile. So if you bear with me, I'm going to hop over to Inventor real quick, and I'm going to open up a file. I don't have these things ready to go, so bear with me here. I'm going to go into my 3D annotations. Let's see. I've got an example here. Let me open up the base of this part here. So let's open that one up. So I'm at the part level of this screw jack. So the Annotate tab, you can go to that, and I'm just going to show you a simple dimension tool. So if I click dimension, and just like if I select 2 points, I can begin the placement of the dimension. Now there's a couple of toggles here. You can hit the tab button will align your the tab button will align the text, and the space bar will align what plane you're placing the annotation in. So you can be a bit creative in dropping these dimensions off. And when you drop off the dimension, you do have the ability, just like in the drawing, to add information to the design. So I can come in and add a particular tolerance if I want a classic tolerance, or I can come in and add a note to the dimension if I wanted to modify that. So it is very nice, and I think straightforward to use. If I click it, I've got that dimension. Now the dimension tool, right? The dimension tool, just like anything else, if you select an arc, you will get the radius, all right? And if you select a circle, let's see, that's not a complete circle, but I can right click on this and dimension type, put diameter here so it's close enough that I can run a diameter. Sometimes the plane won't, because the circle is a planar object, it kind of locks you into only using that plane. But it's a very straightforward way of adding the annotations to the design. So I'm going to hop back into PowerPoint, and I think anyone, whether you're taking the class or not, you can absolutely jump in and add some dimensions on your 3D model, and it's very straightforward. If you can do it in the drawing environment, you can do it here. There's actually, I don't have it in the PowerPoint, but there's actually at the end of this, when you go to drop your drawing, if you put your drawing in a drawing view, you can actually go get these 3D annotations and have them appear on the drawing sheet automatically. So there are other ones. There is the angle dimension is of course there if you need it. linear and align dimensions if you need those. All right, the next command is the whole note command, and of course this command works directly with the whole command that you use to create the features. And I'm teaching a class this week. I do want to call out the students in my class this week. They are we're doing Inventor Basics this week, and they actually had to take a late lunch today so I could come and teach with you guys today, or to do the webinar. So I want to give them a shout out. Appreciate that. But we just got finished that part of the basics class where you tell them, listen, if you're going to drill a hole, you want to use the whole command, because all the information that's necessary for that mechanical feature is built into that command. And you want to annotate it with the whole note command when you're in a drawing. So they're going to do that tomorrow, but let's jump back over to Inventor, and I've got a couple of holes here. So I'm going to get rid of that dimension. I should have used a whole note for that. And it's the same exact thing. I could come in and drop it off. In this case, you see the information to come in, and I could come in and grab this whole note. It's one thing I don't like about these commands is you have to start them each time. There doesn't seem to be a good apply. So I could do a number of them in a row. And of course, as soon as I say that, there's the apply button right there. There's another hole over here. One of the things you'll notice about these annotations is they always face forward. The text in Inventor, the text always faces forward, which is really nice. It's only in Inventor though, but I could grab that one. I'm hitting the tab button to change my alignment. And of course, if you double click them, you can get back in and edit. And it is, if you've ever added a whole note to the drawing environment, you know that there's a dialog box to edit the whole note. And you can get into the same dialog box here. So for whole count, if you wanted the depth, the counterbore, any of the information that you're used to adding into your drawings, you can add that information via the dialog box that you're already used to, but you're just adding it as a 3D annotation. All right. The next command would be the surface texture. Very straightforward with surface texture. I think it works, to me, it works exactly like it does in the 2D drawing. I don't know that I would have any particular use of it here for real, but I can select a face. And then here, again, I can hit the space bar because one plane might be a better fit than another. But when I drop it off, I have really the same dialog box I'm used to. I can come in and set up my values for my finishes and get those in there very, very quickly. So if you remember, dimensions, tolerances, fit and finish, these are the things that you're interested in really at the part level for part manufacturing. Datum targets. All right, so setting up your datums, this goes a little bit along with the GD&T, but there are particular times when you need to declare faces or edges, and of course, the datum identifiers are available for you here. I'm not going to give you too big of an example of that. I'll be honest, I'm probably not the greatest person to be talking to about GD&T. I don't use it. I've never used it in production, but I have taught the class, and the material is very, very illuminating. But again, setting up your datums is going to be critical to the geometric dimensioning and tolerancing aspect. All right, now the leader text. To me, the leader text is one of the most, I guess, versatile 3D annotations because it utilizes the text editor while you're in model mode. So when you're dropping in a leader, you get to put all kinds of information at the end of the leader. So if you bear with me, I'm going to, let me hop back over here to my, my screw jack. And I'm going to give you an example of this, and then I'll probably delete it. But on the Annotate tab, I can select the leader command. And let's say I want to leader this screw, so that one came in at a good angle. But enter. And then here's the text editor. So I could type in whatever I want. I could type in locking screw. All right, that works just great. But it's, Inventor is a parametric application. So what I could do is come in and say, standard eye properties. Maybe I want to grab the part number and add that. All right, so that way it officially lines up with the file name, and I can hit enter, and maybe with eye properties, I can come over and grab the material and I can add that. And again, parametrically, if this ever changes, then these annotations would update automatically. So I truly do like the leader command. It's just extremely useful. Sometimes I might want to, I might modify one of the leader-based dimensions to kind of do the same thing. But in most cases, I think the leader is just a great tool to have when you're calling out component names, material types, things like that. So I'm going to cancel this because I've got this already set up. I've got plenty of these already in this particular file. I'll hold that for later. But the leader command, excellent excellent tool to use. All right, the general note. All right, so quite often in your design, you're going to need some general notes. These could be just general information about fabrication or general information about the design, particular static parameters or the default tolerances that you want to add. For whatever reason, this is another tool that takes into account and uses the text editor so that you can apply this. Now, let's see if I've got my front view. Here's my front view of this jack, and I've got my design views. We'll talk about this in a minute, but I already have a general note information in here. So these little jacks, these little jack screws, you put them underneath of your heavy machinery, your heavy fabrication machines. You use these to level out the machines, and that's what the general note is talking about here and how this particular design works. But if I were to hop over here, I could run the general note command, and you select an area of the screen. So if I click here, I could sit here and just add the general notes, and this could be a number of different things. Again, I could come in and grab standard eye properties, and I don't know what I could grab the part number. Again, I could go grab the material, and I could put this information up, and it stays forward facing no matter what I'm doing inside of the model. I do have a little example of this, and Lori was she was wonderful in mentioning that I've done a couple of webinars here lately, and I think 2 webinars ago we did like things you didn't know Inventor could do, and this example I'm going to share with you was one of those things. I'm going to go to File New, and I have a custom template. So I have a custom template for a bounding box. I got a 3D router downstairs. I got a CNC router down in my garage. I have the X-Carve, and here lately they've introduced some 3D technology, so I can carve these 3D parts out of wood. It's really nice. But I found myself needing the bounding box of these complex objects, and gosh, trying to find the size of a bounding box in Inventor, not very fun. So what I did is I came into this file, I set up an iLogic rule. I'm not going to teach you guys iLogic, but it's a very simple rule that defines the X, Y, and Z length, width, and height. It also defines the CG of the part, and in essence helps me to develop the information for the bounding box. And then I set up a parameter, so for the X, Y, and Z length, and I set up the parameters for the CG. So in my annotate page, and my general note, if I select it, I reference those parameters into my general note. So if I were to, let's say, go to the Manage tab and bring in a part. So I'm going to derive a component, and I'll go out here and grab something fun, which I actually did carve this on my Xcarve. So I'll bring in this skull, I'll click OK. And you would imagine trying to find the bounding box of this would be a pain, but now it reports to me right away that specific information about that particular object. All right. How I got this skull into Inventor, that would have to be the subject of another webinar. Photogrammetry, there you go. I used photogrammetry to do it. But anyway, there you go. That's a use of the 3D annotation, and specifically the general notes, to just do something that I might need on a typical, in a typical template. Doesn't this particular, I'm just using this for information. I'm not really going to export this to anyone else. I do want to shout out, give a shout out to a guy named Neil Cross, and he has a YouTube channel, and I discovered this tip from him, so I definitely want to give credit where credit's due. So back over here to PowerPoint, the general note tab is great. And again, I could have done the same thing with the leader command because they use the text editor. The general profile note, it kind of goes along the same mindset as the general note. It uses a corner of the page, and it basically allows you to specify your general profile information. So for instance, unless otherwise specified, I want to finish this to a finish of, whatever value you want to have. I will say this, you only get one profile note per part. So it's the nature of the tool to be, kind of all for the one note for everything. So, and it does kind of append itself to the general note. If you have a general note and you click this, it just appends that information to the general note. Now, one more, and I can't show you this one, and I feel so bad, but I'm on a big project and I can't upgrade to 2024 yet. I've kind of been itching to do it, but I've got some really big projects in 2023, and that's what I'm sharing with you today. But in 2024, they added 3D annotation support for weld symbols. Now, we had 3D weld symbols prior to this, but they didn't behave like all the other 3D annotations. They were unique to the weldment environment. And now you do have welding symbols available as 3D annotations. I went into one of the beta testing platforms the other day. I grabbed this image. There's the icon for it. It's the same weld symbol dialog box you're used to from all the other Inventor applications. So you can now come in and add your own weld symbols. And you can do this at a single part level, right? Or you could do it, I believe, at an assembly level. It makes more sense to do it at the assembly level. But at the part level, I might doctor up, like I did the chamfer here, to show where the weld goes or something like that. And just like the weld symbols in Inventor in the other dialogues, you can have your own presets. So once you set up a weld symbol once, you can then save it as a preset, and you don't have to set it up each time. You can just pull it from the drop-down window and make your life a little bit easier. Now, I do want to point out, all right, I love Autodesk, love them to death. And I mentioned Newport News Shipbuilding and how they have adopted this, and they adopted this like 15 years ago. And again, you can go online and you can watch them build units, and there are no drawings. Just everyone's walking around with a 3D model on a Windows Surface tablet. It's amazing. So they have done a great job at this. But I will say at this point, that's all the annotations that Inventor gives you. That is it. There are no other ones. And you might be saying to yourself, oh, what about like bill of material? Or what about balloons? What about some of the other views that you generate in your drawing? They're not supported yet. And I don't know if it's even on the board for Autodesk to add more to this. So I want you guys, I want to be a trusted advisor. So what you see at this point is all that's here. So keep that in mind, that you will find, eventually you will find some annotations that just, you know, they're available in the drawing mode, but they're not available in the 3D annotation area. So I did mark up the annotation scale. So the annotation scale is by default automatic, but you can change it if you go into a design view. So if you set up your design views, you can control your annotation scale. You can also control, I didn't put it in here, but you can also control annotation color. So each individual annotation can be a different color depending on you know, your workflows. Color might mean something. So you can set those things up. What I'm going to do, I'm going to jump into my jack screw here, and you can see that I used design views to kind of mimic the views that I think you would see on a drawing. Now they are 3D, so when you come into the front view, you know, you can orbit it if you need to. But I also have my right isometric view. You'll notice that I have dimensions and the annotations there. So there is a method for declaring which annotations are on which view, which annotations are visible in the view that you're working on. I've got a right view. There's the base part by itself. There is the base view from the left side. And I've got one here, front right ISO. Now, listen, I like these little section views, and I use these in the presentations. But again, as a trusted advisor, I just feel like I have to say this. The section view, like you see here, it does not export to PDF. It does not export to, well, it exports to DWF, but I don't have a lot of people using DWF much. So it doesn't export to 3D PDF. So just keep that in mind. This does a very good job of, you know, a pictorial. Like if I do a screenshot, it looks great. And that might be what you're going for, just screenshots. But so the section view is something you can incorporate. Now, if I go over to the browser, once you start 3D annotations, you're going to get a 3D annotation folder, and all of your annotations will be listed here. And what you do is you go to each view, like here's my default view, which I don't, look, I have all of them turned off. Or I go to the front view, and then you'll see that only some of them are lined up with the front view. Typically, what I have done mostly is I'll add my annotations and then simply go to each view and highlight the ones I don't want and hide them. So there is a bit of jumping back and forth when you're setting up your design views, getting it to show the proper annotations on each view. So there is a little bit of that in the background here. And let me see if I can't open another file real quick. Let's see. There we go. Here is a part that I did. I did this part like the year that 3D annotations became available. So this one is a little bit dated, but it has the same general effect. Over here, you have design views. So I have my isometric view, which don't look, has everything showing on it. But when I go to my front view, you'll see that I've tried my best to turn off any view that's not parallel to this view. Same thing with my top view, my right side view, ISO section. Again, that ISO section looks good. However, that only really works in a DWF file, and then the left end and the GD&T. So just keep that in mind. There is some work in declaring which annotation is valid for the views that you're in. All right. Exporting. So I had a lot of fun with this. And I was looking at some of the new export stuff, and if you're going to get into this, you are going to have to at some point settle on a file format that you choose to export, because we can't put Inventor on those iPads, right? We need to have a viewer on the iPad, and what we'll do is send the people the 3D PDF or the DWF file, or we'll set up a website so that they can pull the stuff off the cloud or something like that. That's a shared view. All right, so there are several options available to you to share your data, and you're going to have to find the one that you like. Each one of them, I think, has their pitfalls. Each one of them has their shining moments, and each one of them has their limitations. I could have made a chart here, but I think it would have taken a little more time than I had to invest in it. But the main exports are 3D PDF, DWF, or shared views. Those are the ones that allow me to export this and get it onto somebody's tablet. 3D PDF, all right? Good format. Let me see if this will work. I'll try it. There we go. Here's my 3D PDF file. So I can export my views. So I can come in and click my views in the 3D PDF document. I get to choose which views I want to share with my team. And this is 3D. So at any given time, they can sit here and spin this around. You can, I believe, enable measure and markup. All right. But the section views, they do not go to 3D PDF. Those little section views I showed you earlier, those don't translate. So you have to kind of avoid those. With 3D PDF, you're going to have to set up your template. There's a PDF template, and you will have to rely on some Adobe tools to set up your template the way you like it. So I'm using the default format that came with Inventor on this one. All right. I think the quality is pretty good on the image. I think it could be a little sharper, but for what it is, I think it works pretty well. And you can attach a step file. That's something I think is unique. You can attach a 3D model to this, so when you export it, you can send them the model too. DWF, again, I think is pretty good. Okay, I guess DWF is getting a little bit older, again, I'm not going to knock it. I think the quality is pretty good. All of your views, you have to kind of know where to go to find these things, but I can get to my front view and I can get to my top view. I do have to, have a little bit of understanding of the navigation inside of a DWF file. And I'm showing you this on the computer. The tablet interface is a little bit different from this, so you definitely want to try it out on the tablet to make sure it's looking good. But of course, measure and markup is all here. This is a savable file, so this might go back and forth between people and as they add notes to it. I think I've got most of that there listed. So again, I didn't do it, but DWF is the only one that supports those section views. And then finally, shared views. Now my shared view, I'll try this and see if it populates. Yes, it did. So a shared view, if you haven't done it yet, it's really nice. A shared view will post this on the internet for you. So it posts it up on the cloud. And again, you can go to your views. So I can have all of the different scene. Oh, I'm sorry, that's the one thing it doesn't do. It's only one view. So you only get one view per shared view. That's shared views. So that's the one knock against it. But I like the quality of this one. I think this is probably the best visual quality. Of course, measure and markup is here if you need it. And then comments. So kind of like Facebook or one of those social media sites, you can run and open up for comments and people can comment back and forth. And again, like a social media site, this view is only good for 30 days. You can extend it if you have to, of course, but there's a natural conclusion to the sharing of the view, which in the traditional file formats we don't typically get. So each of these that I've brought up has, benefits where they shine. Each of them might have a little pitfall, depends on how you want to deploy it down in the shop. And of course, if you're going to go down this route, you have the other investment of putting devices in the hands of your fabricators. That's something that you wanted to think about. Whether you go with Windows Surfaces or you go with iPads or some other kind of tablet, you want to think about that, how you're going to deploy that. So there's also exporting the CAD format. With 3D annotations, if you watch up on the screen, there are two file formats currently in Inventor that support 3D annotation: the JT file and the STEP file. If you use STEP, you've got to use the standard 242. That's the one that supports model-based definitions. The 214 and 203 do not. So JT, Juniper Transfer, that does, and believe me, I know about JT files from working with those shipyards and dealing with those 3D annotations. So once you start putting this in your 3D model, you're going to want to export it to other systems, and there you go. So these are the file types that support 3D annotations. All right. With that said, I've come to the end of this, and I know this can be like drinking from a fire hose. This is not training. This is just an informative discussion about the techniques. If you've got real world questions and you need to get in contact with us, get your IMAGINiT account manager on the line and set up a time. Of course, we can do demos or consulting calls with you and really get you possibly enrolled in some of the training classes that are available for not just 3D annotation, but really all of Inventor manufacturing or product design manufacturing collection, all of those tools. So I appreciate everybody's time and effort in being here, making the time for this, and I will open up the webinar for questions.